of the liver is to receive and take up nutrients and other molecules absorbed from the intestines before the blood is returned to the heart via the inferior vena cava.
The liver
has dual blood supplies, one venous and one arterial.
The portal vein,
which carries blood from the spleen, pancreas, and intestines, contributes about 75% of the blood volume to the liver. This blood is rich in nutrients and other absorbed molecules, but relatively poor in oxygen content.
The hepatic
artery, a branch of the celiac trunk from the abdominal aorta, contributes about 25% of blood volume entering the liver.
This
blood is well oxygenated, but nutrient poor.
Blood from the
portal vein and hepatic artery mixes as it enters and passes through a liver lobule, the classical structural unit of the liver.
Blood then
percolates through the lobule and is collected by the hepatic or central vein. Central veins unite to form larger sublobular veins, which ultimately join the hepatic veins. Blood flows to the heart via the inferior vena cava.
Bile
comprises the exocrine secretory product of the liver.
It is stored in
the gallbladder.
During digestion,
bile is released from the gallbladder through the cystic duct into the duodenum to aid in the digestion of fats.
The filtration
of blood and the production of bile takes place within the structural and functional unit of the liver, the lobule, where the terminal branches of the vessels carrying incoming and outgoing blood meet.
The liver
lobule is roughly hexagonal in cross-section.
In the center of
the lobule lies the central vein, which collects blood from the lobule and carries it to the hepatic veins.
Located
at the lobule periphery are branches of the vessels supplying incoming blood, the portal vein and the hepatic artery.
Also located
here is the bile duct.
Collectively,
the portal vein, hepatic artery, and the bile duct together comprise the portal triad.
Taking
a horizontal cross-section of the lobule gives us an arrangement typically seen in histological preparations.
In this view,
we can identify the central veins and associated portal triads.
There
are two prevailing views of liver lobule organization,
the classic liver
lobule, or anatomical model,
and the liver
acinus.
The classic
liver lobule is based on the structure of the lobule we just discussed. It is hexagonal in shape and is defined by portal triads surrounding a single central vein.
To identify
a lobule in a histological slide, first find a central vein. Next, locate the portal triad surrounding that vein, usually about 6 at the corners of the hexagonal prism.
An imaginary
line connecting the triads represents the outside border of the lobule.
In the classic
liver lobule, blood flows from the portal triads toward the central vein.
Bile flows
in the opposite direction,
from the
central position toward the portal triads of the lobule periphery.
Remember,
the classic liver lobule model emphasizes the anatomical structure of the lobule.
The liver
acinus is another way to view liver structure.
This model
is important for understanding liver physiology and pathology.
The structure of
the acinus overlaps two classic liver lobules.
The
acinus is diamond or oval shaped. It involves approximately 2 portal triads and 2 central veins.
To identify
the acinus, find 2 adjacent portal triads.
This makes
the short axis.
Next,
find the closest central vein on either side of the triads.
This is
the long axis.
The resulting
shape is a diamond or oval.
Blood still
flows from the portal triad to the central vein,
but within the
shape of the acinus, the flow is from the center to the periphery.
Bile flows
in the opposite direction, from the periphery towards the center.
The acinus
model is important because it emphasizes the metabolic differences in hepatocytes between the portal triads and the central vein.
The cells in the
acinus are divided into 3 zones and are numbered in the direction of blood flow, from 1 to 3.
Cells in zone 1
lie along the short axis between the portal triads. Thus, these cells are first to receive everything in blood, including oxygen, absorb nutrients, and absorb xenobiotics. Cells in zone 2 have characteristics intermediate between the cells of zones 1 and 3. Cells in zone 3 are closest to the central vein, and therefore are the last to receive incoming blood. As blood moves towards the central vein, it becomes depleted of oxygen, nutrients, and xenobiotics. To review, the liver lobule is the anatomical model. It is hexagonal in shape. It involves one anatomical liver lobule,
and blood flows
from the periphery to the center.
The liver
acinus focuses on function.
It is diamond
or oval shaped.
It involves
two adjacent anatomical liver lobules.
The blood
The blood flows from the middle, which we discussed as a short axis,
to the periphery.
to the periphery.